Hi everyone, my name is Kexiang Huang. Today I will present our work, Monkey See, Monkey Break, Study of Rule-Breaking Imitation in Virtual Crowds. First, let's look at a common phenomenon in our daily lives, rule-breaking behavior. We often see instances like jaywalking or walking on prohibited grass. Understanding the underlying mechanisms of these behaviors is crucial. It helps us not only plan better physical environments in the real world, but also simulate more realistic crowd behavior in virtual reality. However, real-world field study face three major limitations: safety and ethical risks, uncontrollable environmental variables, and limited access to precise individual data. This brings us to virtual reality. VR offers a highly controlled, producible, and ethical safe alternative. While current VR research has explored crowd imitation, it primarily focuses on extreme scenarios like fire evacuations or simple gates following. What is still missing and what we try to address is the imitation of everyday happening rule-breaking imitation in VR. Specifically, we formulated three core questions and hypotheses for our VR study. First, does the imitation effect transfer to VR? Hypothesis 1 assumes that participants' decisions will indeed be influenced by the surrounding virtual crowd. Second, is this behavior consistent? Hypothesis 2 assumes that if a user breaks a rule in one scenario, they will show a consistent tendency to break rules in others. Finally, what drives these set decisions? Hypothesis 3 suggests a correlation between these high-level actions and low-level individual behaviors, for example, the visual attention. To answer our research questions, we built a freely navigable virtual city. For movement, participants use the right joystick for continuous locomotion and can physically turn their bodies to change directions naturally. For guidance, their left hand holds a virtual smartphone, acting just like Google Maps, to show their next destination. We integrated our four scenarios into a single virtual city. To prevent bias, we disguised the study as a continuous navigation task. Users follow navigation points across the city to collect a virtual coupon and a virtual gift. To populate our environment with a diverse and natural-looking crowd, we selected a total of 50 unique character models from both Mixamo and the Microsoft Rocketbox avatar library. For their movement, we relied on a force-based crowd simulation model and motion matching for their natural animation. However, there is one exception to our standard animation approach. For the red light crossing scenario, we utilized the one-man crowd paradigm to capture the realistic perceptual cues and hesitation shown in jaywalking. With the basic movement and animations ready, we classified our virtual crowd in two distinct behavioral types: rule-following characters and rule-breaking characters. These characters are programmed to either strictly adhere to or actively violate the social norms in each sub-scenario. In our first scenario, the park walk, participants navigate from the entrance to the exit of the park. The rule-following characters stick to the paths, while the rule-breaking characters break the rule by walking on the grass. We test this across three conditions: 0%, 25%, and 50% rule-breaking characters. In the unsignalized street crossing, participants cross a street without traffic lights. Here, the rule-following characters safely use the zebra crossing, while the rule-breaking characters break the rule by walking outside its designed safe zone. In our third scenario, participants cross a signalized intersection. The red light lasts for a full 60 seconds. Here, the rule-following characters wait patiently for the green light, while the rule-breaking characters draw walking during the red phase. replaying those natural one-man crowd animation we captured earlier. Also, please note that to maximize realism, both this scenario and the previous one have moving vehicles on the road. Our final scenario is the shop queue. Participants encounter a line of people walking for a free gift. Here, the row-following characters wait patiently in line, while the row-breaking characters break the row by cutting straight to the front. Once the participant claims their virtual gift, the VR experience ended. To prevent learning effects, we used a between-subject design with 65 valid participants. Each participant experienced all four scenarios under one assigned rule-breaking character's condition: 0%, 25%, or 50%. Afterwards, they completed a post-experimental questionnaire. Our data collection has two phases. During the experiment session, we fully recorded participants' eye tracking, controller inputs, and spatial trajectories, concluding with a questionnaire. Crucially, by using a fixed random seed, we were able to precisely replay their sessions later during the post-process session. This allowed us to accurately calculate their rule-breaking extent and label their specific gaze targets. First, we quantified the extent of rule breaking for each scenario. We used spatial deviation for scenario 1 and 2 and time deviation for scenarios 3 and 4. As you can see in the chart, our statistical analysis revealed a clear pattern. Rule breaking significantly increased in scenario 1, 3, and 4 whenever violators were present in crowds. The only exception was scenario 2, which showed no significant differences across three conditions. However, if we look at the trajectories, a clear visual pattern emerges. Rule-breaking participants in conditions 2 and 3 preferred diagonal crossing paths. In contrast, those in condition 1 still chose the shortest perpendicular route to minimize their exposure to traffic, even when ignoring the crosswalk. Overall, these findings support the hypothesis 1, showing that the presence of rule-breaking characters significantly increased participants' likelihood of rule breaking. This figure shows a pattern of behavioral consistency. Simply put, participants who heavily broke the rule in one scenario tended to break them in others, while rule followers consistently adhered to the rules. So our result partially support hypothesis 2. Although participants' behavior varied across scenarios, they showed consistent patterns, particularly as the number of rule-breaking characters increased. Next, we analyzed the eye tracking data by classifying participants' gaze targets. Statistical tests revealed a very clear pattern. Rule followers spent significantly more time looking at other rule followers, whereas rule breakers focused their attention on the rule breakers. We also mapped each participant's gaze over time, as shown here for scenario 3. The vivid color showed what they are looking at while awaiting, and the faded color showed their gaze after they began cross. This allows us to pinpoint exactly what they held their vision attention right before they made a decision. Finally, this study marked one of the first attempts to systematically analyze the pedestrian gaze related to rule breaking, laying a valuable foundation for future research. Next, let's discuss our study's limitations and the insights they provide for future VR research. First, characters interaction. Currently, our agents don't react to rule violations. Adding social frictions like disproving glares will allow future studies to measure the impact of social sanctioning. Second, rule breaking proportion. We found that too many rule breakers breaks immersion, but zero rule breakers also feels unnatural. To build a socially believable crowd, we recommend keeping rule breakers below 25%. Third, environmental cues. Participants noted that the car density heavily influenced their decision. Future work should integrate advanced traffic simulation to better evaluate risk perception. Finally, it's about study limitations. A fixed scenarios order may have introduced learning effects, and the specific geographical and social background of the sample may limit the generalizability of the findings. Thank you for listening.